Okay, so what's the longest distance between 2 points in 0 dimensions?
Well, I guess there aren't really 2 points, so just 0.
Okay.
So you can't go anywhere.
Can't go anywhere.
Alright.
What's the longest distance between 2 points in 1 dimension, in our 1-dimensional cube?
Well, starting point and the end point, so 1.
Okay. How about here? In the 2-dimensional
Well,
cube?
it would be this long diagonal here, would be your distance. And so each of these distances are 1, and so from that we know that this is root 2.
Okay. So it's actually interesting. So we go from 0 to 1 to the square root of 2. And
Yeah.
now, let's see if we can figure out the longest distance in the 3-dimensional cube.
So this would be this diagonal, or from 0, 0, 0 to 1, 1, 1.
Okay.
Thinking about it that way. And so we know this distance is root 2, and we know this is 1, and so we can create a right triangle that has hypotenuse root 3 now.
Alright.
So your long distance is root 3.
Alright.
So root 3 for this case. Can't really draw that in.
Now we can't really draw it in, but that's certainly very interesting. And now let's see, even though we can't visualize really well this shape, we have a representation of it. Let's see if we can make an argument about what the longest distance would be in the 4-dimensional cube.
Well,
Maybe I'll erase here just so you can keep this on the border. Do you want to switch the places? You can write root 3 over here if you want.
so I would think about this, because there has to be 4 different directions you can go for the 4 coordinates. So we have moving this way, back and forth along this axis is 1, up and down this way, and then in the z direction, that's 3, and then for the 4th one it would be going into this inside cube, so moving along these yellow lines.
Okay.
And so that would make 0, 0, 0, 0 here, and then you go 1, 1, 1, 1 is here.
Alright. So how do you think we can find that distance from 0, 0, 0, 0 to 1, 1, 1, 1?
Well, we have to. Maybe we could. It's we can't really figure out how long this will be. Well, however long this distance is, it's still 1 in that direction.
That's right. So those, even though our representation has them as a slightly different distance, just to help us see it, it's still 1.
Yep. Well, we could maybe think about it using a pattern almost, because if you look at 0 and 1 as instead square root of 0 and square root of 1,
Mm-hmm.
and then 4 we had square root of 2 for the square and root 3 for the cube, maybe it would be root 4, which would be 2 in the 4th dimension.
Okay. And how do you think we're gonna see that? It's a very good guess. It certainly would follow the pattern: 0, square root of 0, square root of 1, square root of 2, square root of 3, square root of 4.
Well, I'm not too sure.
Well, how did you see it in the 3-dimensional cube? How did you see that we got to root 3?
You created a triangle with your previous distances. You had root 2 and 1 here. So
Okay.
the 1-dimensional distance and the 2-dimensional distance.
And those were perpendicular.
Yep. So I guess you would use your other previous distances, or you could also use this 1 length. So
Okay.
you use 1 and you use root 3 as your 2 lengths of your 2 legs of the triangle, and that would make the hypotenuse be square root of 4 or 2.
Okay, so why don't you just draw out what that triangle is? Here, I'll move this over here. So what is the triangle we're actually going to be looking at in 4 dimensions?
So we have, I guess, this one side, and then 3 and 2. And root 3 is the longest distance for a cube, so this will be the axis of a cube, and then that'll be created by a 1 and a root 2 face, or root 2 edge.
Yeah, so there we go. So we got it. So we know that this triangle gives us the longest distance in a 4-dimensional cube. And it turns out that the distance from the 2 opposite corners is
2.
2 on the sideless one. So that's cool.
Yep.
Alright, good work tonight, huh?